So the next thing that we're going to talk about is engine classification and how we identify different engines. Why do this? Why come up with a vocabulary specifically to describe engines? Well, if you look at the photos that are appearing right now, what you'll notice is that there's a great diversity of the different types of automobiles that exist. Everything from daily drivers to supercars to heavy-duty trucks, all the way back to antique vehicles. And because of that diversity, it can be very helpful when discussing vehicles to have specific words that help us understand exactly what's going on and what the construction looks like. It's also helpful during this exercise to be specific about the type of motor we're talking about so that technicians and owners can recognize the kind of engine they have and also the different components you find in each of those engines. So one of the first ways that we identify our engine is by the number of strokes that it makes. So most automobiles use a 4-stroke engine, which is pictured in this image here. We've talked about the 4-stroke in a previous video, but most automobile engines are going to abide that structure. They're very commonly manufactured that way, but there are exceptions. For example, this in the top right, you may have heard of a rotary engine or a Wankel engine. Instead of pistons, this has a wobbling semi-triangular, semi-round rotor inside that as it wobbles or rotates around a central shaft, it creates the compression and force needed to drive the powertrain. Additionally, you might have more exotic drivetrains like this one in the bottom right, which is an honest-to-goodness turbine engine. That's right, the same kind of engine that you might find in an aircraft drives this particular old, I believe, well, I'm not going to take any stabs at that. It's an older model car, and they are extremely expensive to manufacture because of how specific the tolerances must be. So the number of strokes is the first way we can classify engines. We can also take a look at the cylinder arrangement in our engines. So this image here is a very common arrangement known as inline. You'll see this is a 7-cylinder inline engine, and you see one after the other, the cylinders make a single line. Very straightforward design. We have the V-type, which if you look at the two, these are the actual heads on this engine. When looked at from the side, they make the letter V. So the crankshaft is down here in the crankcase, and the pistons ride up in their individual channels that make this V shape. This right here is an engine you might find on a motorcycle or a scooter. And then we also have horizontally opposed engines where the cylinders are actually laid flat, and you can see in this image where the pistons are riding along their cylinder housings on the opposite side from one another of the crankshaft. This is also referred to as a boxer or a pancake engine. So this is another way we can categorize engines, is how their cylinders are arranged. We can also talk about the direction that the engine is mounted in the vehicle. The first one we're going to talk about is longitudinal mounting. And what longitudinal mounting means is that the engine, the front and the back of the engine, correspond to the front and the back of the vehicle. In this image, you can see that the engine is in line with the drivetrain, in line with the drive shaft. And actually the flywheel would be found at the back of the engine here, where it connects directly to this oblong-shaped piece, which is the transmission. Longitudinally, it means, I'm going to come up with ways to remember this, but we have longitudinally, it goes along the direction of the car. Conversely, we have a transverse mounting direction. If you look at this image, you'll see that the engine isn't in line, it's not along the car, it's across the car. So the cylinders are across the line of sight of the driver or across the under the hood, and you can see over here the cooling fan is connected on this side, which might mean that the flywheel is on this side, as opposed to the flywheel being on the rear of the motor pointing back towards the rear wheels. In this vehicle, the flywheel is pointing to the right side of the vehicle, or to our left in the image. So longitudinal and transverse mounting directions. We can also talk about the valves and the camshafts, how many there are, and the location inside of the motor. So these two images show two different types of engines. One that has overhead cams. You can see in this image, if the pistons are riding along this area here, it means that the cylinders wrap around them, and the cams are positioned over the valves. That's why they're called overhead cams. And you can see that there are two camshafts, 1, 2. So we have dual overhead cams. On this side, we have a push rod system. So they actually don't have the camshaft pictured here, but in the block of the engine, in the same block where the pistons ride inside the cylinders, there would be a camshaft where the lobes would pick up on these rods, these push rods, and when they push on the push rods, they come up to this rocker arm, which then connects to the valve stem and opens the valve to allow air in or exhaust out. This is called a push rod organization, and the cam is in the block. So these are two very different operating methods with the engines, but both of them exist in modern automobiles. Overhead cams, dual overhead cams. This one has 4 valves per cylinder. This one looks like it only has 2 valves per cylinder. So all of these details can be helpful when identifying the motor. Some other features that are worth talking about is the type of fuel they have, the cooling method, and induction method. So type of fuel very commonly is going to be gasoline or diesel. Cooling is typically done via liquid or water, or you might hear water-cooled or liquid-cooled engines. Older engines are often air-cooled. Modern vehicles are liquid-cooled. And by induction, I mean whether or not the vehicle simply pulls air in from the suction of the pistons, which is natural aspiration, or whether or not it's turbo or supercharged. So over here we have a turbocharger connected to a motor. So there's one turbocharger, and if one turbocharger is good, then 2 turbochargers or twin turbocharging must be better, right? When it comes to horsepower. A turbocharger actually forces air into the intake system, which helps more fuel burn at the same time and generates more power. So turbochargers are like vacuums that suck air into the engine and help it burn more fuel at the same time. The last thing that we will talk about as far as identifying an engine is the rotation direction. Now, when we're looking at the engine from the flywheel end, the end here, this big wheel is the flywheel. The SAE standard, or the Society of Automotive Engineers standard, is that the motor turns counterclockwise. So this flywheel would rotate in this direction. The top would move to the left. So if we're looking at the engine from the other side, the engine would appear to move clockwise. So we always want to make sure that we're talking about, when we say clockwise or counterclockwise, we want to know which direction we're looking at the motor to. Not all motors adhere to this, but this SAE standard is a good rule of thumb. Be careful, make sure you know your engine when you're working on it. Up next, what we're going to talk about is engine forces and their measurement. Thank you for listening.